this next video, we're exploring how algebraic equations connect to functions and relationships. An equation with two variables show the relationship between the two variables. We can represent this relationship as a table, as a graph, sets of ordered pairs, or as an equation. When you have an algebraic equation with two different variables, and you know the value of one of the variables, you can substitute that value into the algebraic equation to find the corresponding value of the other variable. For example, y equals 2x plus 5. If you have either the x or the y value, you can substitute it into the equation to find the other value. Let's have a look at a couple of examples. Our first example reads y equals 3x plus 5. The first input value, or x value, is negative 2. We will then substitute the x in our equation with the value negative 2. Our algebraic equation now reads y equals 3 times negative 2 plus 5. If we complete the calculations, we will find negative 6 plus 5, which will give us an answer of negative 1. Y equals negative 1. We now have the output value, or the y value, when the input, or the x value, is negative 2. This also forms an ordered pair where x is negative 2 and y is negative 1. To finish completing our table, we are now going to substitute the second x value into the equation. The second x value is 1, and we substitute it into the place of the x, and we have a sum 3 times 1 plus 5. 3 plus 5 is 8, which means that if the input, or the x value, is 1, the output value is 8. We now write the corresponding output, or y value, in our table. Our third input value is a 3. We substitute the 3 into our equation. 3 times 3 plus 5. 3 times 3 is 9, plus 5 is 14. We've used the input value 3 to find the corresponding output value, and we can write the 14 into our table. To complete the rest of the table, we need to take a different approach. You'll see that we now have an output, or a y value, instead of an x value. The basic principle still stays the same, and we're going to substitute the 17, which is the value that we do have. This time we're substituting it with the y. The algebraic equation we now have is 17 equals 3x plus 5. Just like we did in the first video, we need to get x alone on one side of the equation so that we can find its value. Firstly, we're going to try and get rid of the plusing 5 by doing the inverse operation, which is minus 5. You will remember that what we do on one side of the equation, we have to do on the other side of the equation. 17 minus 5 gives us 12. Your equation now reads that 3x equals 12. Our next step to get x alone would be to do the opposite, or the inverse, of timesing with 3, which is dividing with 3. What we do on one side of the equation, we do on the other side, and that leaves us with x equals 12 divided by 3, which is 4. You will notice that the x is now alone on one side of the equal sign, which means that we've successfully calculated the x value for a y input of 17. To complete the last space in our table, we're going back to the initial equation, and we're substituting the value that we have, the y value, into the equation. Negative 10 equals 3x plus 5. The first step to get x alone would be to do the inverse operation of plusing 5, which is subtracting 5, which we do on both sides of the equation. Negative 10 minus 5 gives us 3x equals negative 15. Our next step to get x alone would be to divide with 3, which we do on both sides of the equal sign, and x is therefore negative 5. We've calculated the corresponding x value for an y input of negative 10, and we can fill that into our table. We've successfully completed the table and filled in all the ordered pairs that were requested. If you find any other variable like an A or a B, it doesn't make a difference to the approach that you would take at all. You just need to pay attention and make sure that you're substituting the right variable in each case. You might also find an algebraic equation with exponents or roots. In this example, we have y equals x squared minus 3. We go to our first input value. We have an x value that's given, and we substitute it into the equation just like we did in the previous example. Your equation now reads y equals negative 2 squared minus 3. Our first step is to say that negative 2 times negative 2, you will remember that a negative times a negative gives us a positive, and 2 times 2 is 4, which means we have an equation that reads y equals 4 minus 3, which is 1. This means the corresponding y value for an input of negative 2 or an x value of negative 2 is 1, and we can fill that into our table. Our next x value is 1. We substitute it into our equation. 1 times 1 is 1 minus 3. And our corresponding y value for an input of 1 is negative 2. We can go ahead and fill our second y value into the table. Our third x value is a 3, which we substitute into the equation once again. 3 squared means 3 times 3, which is 9, minus 3, which gives us an answer of 6. This means the corresponding y value for an input of 3 is 6. We'll notice once again that we are now given the y value instead of the x value. We go back to our initial equation and we substitute the y with 22. Our equation reads that 22 equals x squared minus 3. Our first step is to do the inverse operation of subtracting 3, which is adding 3. We do this on both sides of the equal sign, which means that x squared equals 25. We now have x squared on one side of the equation. You'll remember that we want to get x alone. Just like we did with plussing, minusing, timesing, and dividing, we have to find the inverse operation for squaring, which is rooting. If we do it on one side of the equal sign, we also have to apply that to the other side of the equal sign, which leaves us with x equals the square root of 25. The square root of 25 is 5, which means that our y value of 22 gives us a corresponding x value of 5. Our last output value is 46, which we are going to again substitute into our equation. Our first step in getting x alone is to do the inverse of minusing 3. We plus 3 on both sides of the equation, which gives us x squared equals 49. Again, to get x alone, we do the inverse of squaring, which is rooting, and we apply this to both sides of the equation, and x equals the square root of 49, which is 7. Another table that we've successfully completed. Remember, just like in our first video with algebraic equations, you can substitute both of these values of these ordered pairs into the equation. Make sure that both sides of the equation have the same value, and that's how you know your answers are correct.